In this video, I'll be explaining Dalton's law of partial pressures. So, Dalton's law of partial pressures. So basically, what Dalton was studying was a mixture of two or more gases. And he wanted to know how the pressure would change when you have more than one gas inside a container. So let's say you have a container that is closed. So you may not only have oxygen, you may have nitrogen there too, and many more gases. And because you usually don't have the same number of moles there, the pressure of each gas will be different. So it will be different. And what he wanted to determine was the total pressure of the whole container using the partial pressure of each of the gases, so the oxygen and the nitrogen. That's why it's called Dalton's law of partial pressures. And it works like this. This is a formula. So he said that the total pressure will be equal to the sum of all the partial pressures. So total pressure will be equal to the pressure of the first gas plus the pressure of the second gas. Plus it could be there could be a third gas, a fourth gas, depending on what you're trying to solve. And well, if you're not given the actual pressure of each of the gases, you can just determine it using our ideal gas law. So it would be PV equals nRT. So nRT over V. For A, let me prove this. For A plus nRT over V for B. Well, depending on what they tell you, the number of moles may be different between each gas. The R is always a constant, so that doesn't matter. The temperature may be different, or the volume may be different, but it usually is only the number of moles what makes the difference. And well, if you have a third one, you just apply the same concept. It is really a basic concept. So let's solve a problem to show you how it goes. So our problem says that we have 3 moles of nitrogen and 4 moles of oxygen. So let's write that first. Nitrogen, the number of moles of nitrogen is 3. The number of moles of oxygen is 4. Then they tell us that these gases are placed in a 35-liter container. So the volume will be equal for both because, they're in the same container. And it's at a temperature of 25 degrees. So 25 degrees. So you can picture it like what I did last time. You have a container, say something like this. It has a top, and we have our oxygen here, our nitrogen here. And well, because it's closed, or so we think that the container, because then if it weren't, the gas will diffuse. The temperature will be equal for both, and the volume will be equal for both. So that's good to know. And then the question is, what will the pressure of the resulting mixture of gases be? So they're asking us for the total pressure. So whenever you have a mixture of gases, you'll want to apply Dalton's law of partial pressures. Now I said in the ideal gas law video that the first thing you want to do is to change the units. So this is fine. The number of moles is fine. So that's checked. The liters is fine, but the degrees Celsius cannot be. So you have to change it into Kelvin. So by adding 273.15 to the 25, we get 298.15 Kelvin. So now our units are fine, and there's one more thing. It's the constant. It's 0.0821 liters atmospheres per mole Kelvin. So all of our units are fine now. Let me erase this. You could solve the partial pressure of each gas separately and then add them up, or just do it in the same formula. I'll do each separate. So the partial pressure of nitrogen would be equal to N nitrogen RT. This is constant, and the volume is constant too. So it would be 3 moles times 0.0821 liter atmosphere mole Kelvin, and the temperature doesn't really fit, 298.15 Kelvin over 35 liters. So that would be about 2.09 atmospheres. So let's separate our data from what we get. We have the first partial pressure, and I'm going to do the second one in the next space, just to have more space. So this is the partial pressure of oxygen, and it would be, we had 4 moles. Our constant 0.0821 liters atmospheres mole Kelvin, and then it was our temperature, so 298.15 Kelvin, and it was all divided by 35 liters, which is the volume. So our partial pressure of oxygen is 2.79 atmospheres. So now we have both partial pressures. So Dalton's law of partial pressures said that the total pressure would be the sum of each. So we have 2 gases and O2. So it would be, let me go back, 2.09 atmospheres plus 2.79 atmosphere is equal to about 4.88 atmospheres. This is our total pressure of the mixture. So remember, whenever you have a mixture, you will want to apply Dalton's law of partial pressures.